Kharkov engineers received the task of creating a flamethrower tank with the most powerful flamethrower in the world. 100 liters of burning mixture must fly a record 270 meters. 16 such shots in a row, an absolute weapon for burning everything alive. The designers make a revolutionary decision. They remove the cannon from the tank completely. The flamethrower becomes the sole main weapon. No one yet suspects what price this brilliant idea will cost. The late 20th century 50s became a time of flourishing for Soviet flamethrower technology. After the Great Patriotic War, these machines did not disappear from the Red Army's arsenal, as many might have thought. On the contrary, Soviet designers continued to improve systems for burning out enemy personnel from cover. The most successful was the Tu-55. On January 17, 1960, it was accepted into service with the Soviet Army by order of the Minister of Defense. This combat unit was built on the basis of the medium tank T-55 and represented an example of a reasonable compromise between firepower and versatility of use. The automatic flamethrower AO2 was placed in the turret in place of the coaxial machine gun. At the same time, the 100mm cannon, the bow machine gun, and all other standard armament were retained. The crew still consisted of 4 men. The flame system was an additional, not the primary means of destruction. The range reached 200 meters, which was a serious advancement. Aimed fire was conducted not only from a stationary position, but also on the move, with a rate of fire of up to 8 shots per minute. This made the Tu-55 a percent for assaulting fortified positions and burning out the enemy from buildings in urban combat. Serial production ran from 1961 to 1973 at factories in Omsk and Kharkov. A total of 830 units were built. It would seem the concept had been found and would develop in exactly this direction, preserving combat flexibility. But the Kharkov engineers thought differently. Special Design Bureau No. 1, under the leadership of Mostovoy, was developing a completely new installation. It received the designation OM-250, where the letters OM stood for Ognomet Moshny, powerful flamethrower, and indeed, in its characteristics, this was a revolution. The capacity of a single shot was 100 liters. This was nearly 3 times more than the ATO-02 and 5 times more than the earlier ATO-1. Such a volume was the maximum limit for jet systems based on the ignition conditions of the combustible mixtures used. Physically, it was impossible to do more, otherwise the liquid simply would not ignite properly. The throwing range approached 300 meters. This was an absolute record for tank jet installations. The ejection speed was 100 meters per second. Imagine 100 liters of burning liquid flying at the speed of a racing car and creating a fire strip 30 meters wide. Leadership of the project to create a combat unit with this monstrous armament was taken by the chief designer of the Malyshev plant, Morozov. And here a choice was made that determined the entire subsequent fate of the development. It was decided that the new installation was so powerful it could become the sole weapon. The cannon was removed completely. The mounting was to be installed on trunnions in the embrasure in place of the 100mm gun. The logic was simple. The increased capacity required an enormous internal volume to accommodate the mechanisms. There simply was not enough space in the standard turret for both systems. At the same time, a specialization was chosen. Since a purely flamethrower combat unit was being created, let it burn everything in its path, but do so with maximum effectiveness. Thus began work on the project, which received the factory designation Object 483. A medium T-54 Billions was used as the base. The hull and running gear remained practically unchanged. The combat weight was 35 tons, which was even lighter than the production model thanks to the absence of heavy artillery and ammunition. Maximum speed reached 50 kilometers per hour. The armor remained anti-shell. All the most interesting things happened in the upper section. The new OM-250 had a cylindrical shape, 1,616 mm long and 280 mm in diameter. Inside, under the action of propellant gases, a piston moved, which pushed the liquid outward. A screw elevating mechanism was used for vertical aiming, and the standard rotation mechanism with an electric motor and manual drive was used for horizontal aiming. On the right, suspended on shock absorbers, was mounted a reservoir with a capacity of 1,600 liters. It rotated together with the upper part of the hull. allowing 14 to 16 powerful salvos. Refueling was carried out through the right hatch in the roof. Since there was no coaxial machine gun in the design, the embrasure for it was simply welded shut. In the rear section, a large round cutout was made, into which a cylindrical nozzle was welded. A vertical pipe with a fan for cooling the gas chamber was welded to it. This pipe stuck out like a strange mushroom, making the appearance completely unlike any other combat vehicle. The only conventional firearm remaining was the bow machine gun SGMT caliber 7.62, installed in the upper frontal plate. The ammunition load was 1,750 rounds. That was the entire arsenal of traditional armament. The absence of artillery and a loader allowed the crew to be reduced to 3 men, a driver mechanic, a commander, and a gunner. The new installation was operated by the gunner and, if necessary, the commander. Fewer people, less inhabited space, more room for combustible liquid and mechanisms. By the end of 1959, the prototype of Object 483 had been manufactured. It looked impressive. A massive silhouette, a sturdy hull, wide tracks. Only instead of a long gun barrel, a short muzzle device protruded. And that strange pipe at the rear, which revealed that before you was an unusual piece of combat equipment, the prototype was being prepared for trials. The military and developers wanted to see how the most powerful system in the history of Soviet tank building worked. 1961, the prototype of Object 483 was delivered to the proving ground of the Research Institute of Armored Vehicle Technology. Here, at the testing grounds near Moscow, all new developments in Soviet tank building were tested. This was precisely where revolutionary projects were brought before deciding their further fate. A commission of military experts and representatives of the Kharkov factory assembled to see what the new development actually represented. On paper, the characteristics looked impressive, but theory is one thing and the actual operation of mechanisms is quite another. The combat unit took up a position on the test range. The crew prepared the system for firing. The reservoir was filled with combustible mixture of the BBU grade, specially developed for maximum range and combustion temperature. The hellish liquid awaited its moment, the command to open fire. A column of flame burst from the short muzzle device. The burning mixture flew out at express speed, turning into a river of fire. The destruction strip stretched almost 3 football fields in length and a third of a field in width. A solid sea of fire from a single salvo. The combustion temperature exceeded 1,000 degrees. Where a moment ago there had been an ordinary test area, now stretched scorched earth. Not a blade of grass, not a bush, nothing living. Only charred soil and tongues of flame consuming the remnants of vegetation. Military observers exchanged glances. They had never seen such power. Previous flamethrower developments looked like children's toys compared to what the OM-250 had just demonstrated. This was a weapon capable of turning any area within its range into a wasteland. The firing continued. The combat unit belched fire, demonstrating the ability to conduct a continuous attack. The mechanism worked like clockwork. The gunner could make ejection after ejection, creating a solid wall of fire. If the launch button was held down, the attack became practically continuous. 1.5 tons of fuel turned into 16 fiery strikes, each of which could destroy everything living over a gigantic area. The Kharkov engineers made no secret of their pride. They had created what seemed to be the limit of the possible. A larger volume was physically impossible due to ignition limitations. A greater range was also unachievable for jet installations. This was the absolute maximum of the concept. Experts recorded the results. Target destruction at distance confirmed. Width of destruction zone measured. Rate of fire recorded. Reliability assessed. In all parameters, the project surpassed any equivalent in the world. The firing did not stop. The proving ground was turning into a scorched desert. Each new attack left behind a strip of absolute destruction. Nothing living could survive in this hell. The heat was such that sand melted, turning into a glassy mass. The demonstration continued. The cooling system handled the loads. That same strange pipe with the fan at the stern effectively drew heat away from the gas chamber, preventing the mechanism from overheating even under intense operation. The reservoir emptied after the full expenditure of ammunition. The last strikes were just as destructive as the first. 16 times the combat unit belched fiery death. A gigantic area of scorched earth. The entire supply had been turned into a weapon of mass destruction. After the completion of the firing tests, a check of the driving performance began. The machine accelerated along the highway, demonstrating acceptable speed. Maneuverability met expectations, protection held. The power plant pulled the lightened hull without problems. Cross-country capability was tested. Climbing slopes was successful. Fording streams caused no difficulties. Ground clearance allowed passage over obstacles. The running gear performed reliably. The guidance system was tested. The screw elevating mechanism provided smooth vertical adjustment. The electric motor rotation drive allowed rapid transfer of fire from one target to another. The manual backup drive made it possible to operate even in the event of electrical failure. Crew ergonomics were evaluated. The driver mechanic noted good visibility and handling. The gunner confirmed that fire control was intuitive and effective. The commander appreciated the ability to conduct fire himself if necessary. Ergonomics were at a decent level. The refueling procedure through the roof hatch was practiced. The process took an acceptable amount of time. Pumping with a special pump went quickly. Maintenance did not require complex operations. Test protocols were filled out one after another. All indicators met the stated specifications or exceeded them. The OM-250 installation performed brilliantly. The chassis demonstrated the reliability of a proven platform. The controls functioned without complaints. The Kharkov engineers rejoiced. Their creation had passed the test with flying colors. They had created the absolute weapon of fire. No one in the world had anything like it. This was a triumph of Soviet engineering thought. The military commission also acknowledged the technical perfection of the project. By purely engineering criteria, Object 483 was a masterpiece. The developers had extracted the ultimate maximum from the concept of jet installations. There was nowhere further to go. The physical laws of liquid ignition placed an insurmountable boundary. The combat unit did exactly what it was created for. It burned everything in its path with unprecedented effectiveness, turned the battlefield into a dead zone, destroyed any target within reach, and did so with technical flawlessness worthy of admiration. The trials concluded, the protocols were signed, the data recorded. The project had confirmed all stated capabilities. The most powerful installation in the history of the USSR worked. Now it was necessary to decide what to do with this technical marvel next, whether to launch into serial production, whether to accept into service, whether to send to the troops. But first, the military needed to discuss one important question that no one had thought about during development. After the completion of the trials, the military began to discuss the practical application of the new technology. Technically, the machine was flawless. This had been proven at the proving ground. But the question was different. How effective is this weapon in the realities of modern combat? 1961 was a turning point for anti-tank defense. Literally on June 15% of that same year, the new handheld anti-tank grenade launcher RPG-7 was accepted into service with the Soviet Army. Aimed firing range, 300 meters armor penetration, 400 millimeters of steel. Any infantryman could carry it and destroy tanks from farther than the flamethrower could reach. This was not the only example of modern anti-tank weaponry. Motorized rifle units were equipped with Recolleus guns B-10 and B-11. The B-10 could fire to a range of up to 4.5 kilometers. The B-11 fired a shaped charge round to a kilometer. The numbers spoke for themselves. Infantry anti-tank weapons engaged targets at 300 to 800 meters and beyond, while Object 483 had to close to within 250 meters to employ its weapon. The arithmetic of combat employment looked catastrophic. The tank begins closing with enemy positions. At a distance of 500 meters, it comes under fire from recoilless guns. At 300 meters, the RPG-7 begins to fire, while the flamethrower only works from 270. What could the machine oppose to this threat? Practically nothing. The only means of fire support remaining was the bow machine gun SGMT caliber 7.62 with an ammunition load of 1,750 rounds. It only fired forward in the direction of hull movement. Largely ineffective against entrenched infantry and useless for suppressing fortified positions. At the design stage, the engineers understood this problem. Originally, it was planned to install a coaxial machine gun in the turret plus 2 aircraft rocket launcher units of 57mm caliber on the sides of the turret. Each unit held 16 active reactive rounds. This would have provided the ability to suppress firing positions at range, but this solution was abandoned for layout and tactical reasons. The OM-250 flamethrower took up too much space. The fuel tank with a capacity of 1,600 liters consumed all available volume. The choice was simple: either maximum flamethrower power or additional armament. They chose the flamethrower. The coaxial machine gun was removed. Its embrasure was welded shut. The rocket launcher units were not installed. As a result, the tank received record firepower at close range but remained defenseless at medium range. The progress of infantry anti-tank weaponry outpaced the progress of flamethrowers. The RPG-7, accepted into service that same year, became a symbol of a new era when infantry gained the ability to effectively engage tanks at medium ranges. The arms race ended with victory for grenade launchers and recoilless guns. Physical laws put an end to the development of jet flamethrowers. 270 meters is the absolute limit. It is impossible to increase the shot volume beyond 100 liters. The mixture will not ignite. But anti-tank weapons developed without such limitations. Another problem made the situation worse. Object 483 was easily recognizable. The absence of a cannon immediately gave away that this was an unusual tank. The welded shut embrasure caught the eye. The strange pipe with the fan on the stern of the turret made the silhouette unique. Any enemy soldier could understand that before him was a flamethrower vehicle, which meant he knew the main thing. This machine is dangerous only at close range. Beyond 300 meters it poses no threat. The enemy could calmly shoot up the tank from a distance, concentrating all anti-tank fire on it. A flamethrower that cannot reach its target is simply a target. Comparison with the Tu-55 was inevitable. That tank retained the 100mm cannon and received the flamethrower A-200 as additional armament. It could fight at all ranges, protect itself with artillery from a distance, and employ flame at close range. 830 machines were produced from 1961 to 1973. Versatility defeated specialization. In the 1940s, during the Great Patriotic War, flamethrower tanks were effective. The Panzerfaust in its later modifications fired at maximum 150 meters, earlier versions at 30 to 40 meters. Anti-tank grenades required throwing by hand. The flamethrower could approach relatively safely to the employment range. But now the situation had changed. RPG-7 to 300 meters, recoilless gun, 1 kilometer and more. Anti-tank guided missiles were appearing with even greater range. The gap between the capabilities of the flamethrower and the capabilities of anti-tank weapons grew with each passing year. The 30-meter difference between the RPG-7 and the flamethrower was a death sentence. On the modern battlefield, the tank would be destroyed before it entered the zone of effective use of its sole weapon. The mathematics of war was merciless. Military specialists analyzed the trial data, acknowledged the engineering perfection of the project, noted the record indicators of the flamethrower armament. But the conclusions were obvious. In the realities of the early 1960s, a flamethrower tank without a cannon was a suicidal concept. In 1962, work on Object 483 was officially terminated. The tank was not accepted into service. There was no serial production. The Kharkov project became the last Soviet flamethrower tank. In the United States, flamethrower tanks of the M67 series were actively used in Vietnam. The Marine Corps used them from 1965 to burn out tropical jungle growth, destroy villages and suppress fortifications. The M67, based on the M48 tank, retained the cannon and received the M76 flamethrower. Flamethrower range from 90 to 180 meters. Flamethrower fuel supply for 60 seconds of continuous fire. 73 machines were in service. But even in Vietnam, where jungle conditions seemed ideal for flamethrowers, they were withdrawn from service in 1972 to 74. No new flamethrower tanks entered service with the U.S. Army or Marine Corps. On December 2, 1983, the UN Convention on Prohibitions or Restrictions on the Use of Certain Conventional Weapons, which may be deemed to be excessively injurious, came into force. Protocol number 3 prohibited the use of incendiary weapons against the civilian population and in forested areas. The USSR ratified the convention on June 2, 1982. By that point, flamethrower tanks had long since disappeared from Soviet forces. The technology transformed into other forms. In the mid-1980s, the TOS-1 Buratino appeared, a heavy flamethrower system of the rocket type, not a jet flamethrower, but a thermobaric multiple rocket launch system. The RPO Schmel, a single-use reactive infantry flamethrower. Aimed range with optical sight up to 850 meters, thermobaric munitions solve the range problem that jet systems could not solve. The single-built example survives. Today it stands in the technical center of Patriot Park, where the Kubinka Tank Museum formerly was located, the machine with the most powerful tank flamethrower in history, which never fired at an enemy a single time. Subscribe to the channel to learn about other failed developments, like if it was interesting.